Welcome back. Here we are, integral or integration of inverse trigonometric what? Function. Inverse trigonometric what? Function. Alright, so as we said, integration is a reverse process of differentiation. And for that matter, when we are doing calculus 1, we established all these that when you differentiate sine inverse, you get this. Sec inverse, you get this. Tan inverse, you get this. And as a reverse process, it's like differentiation will say create, integration will say come and destroy. So when you integrate this, you get sine inverse. When you integrate that, you get sec inverse. When you integrate this, you get tan inverse. Alright, good. Please make sure you look at the difference here so that when we get to integral of hyperbolic functions, you will not be confused. Alright, because it's somehow similar. That is why right after this video, I will be doing integral of hyperbolic functions for you so that you will not confuse yourself. Alright, so now let's start by solving questions. Know all of it, okay? You have to know all of it. So if you have integral of 1 over 1 minus 16s squared dx. How are we going to solve that? Here, we have to let it be in a proper form. Here, we have to let it be in a proper form so that we can relate it to some of these, okay? So let me clear up these parts. Let me clear up these parts so that we can let it relate something like this. So looking at a constant, square root of a constant minus what? Something. Square root of a constant minus something. So it's somehow relating to this. Okay, if that is the case, we can rewrite this question as 1 over 1 minus. This is 4 60, right? So this is the same as 4 squared. So we can write 4s squared dx. And when you write it like that, here now we can let u to, so that we want to get a form like this. So we can let u to be equal to what? 4s. And when you differentiate that, you are going to get you are going to get 4 ds. Okay, so now what is ds? And ds is going to give you what? Du over 4. Alright, so now by substitution, integral of 1 over square root of 1 minus, this is what? U squared. And ds is what? Du over what? 4. Now the constant that we have here is 1 over 4. Integral of 1 over square root of 1 minus u squared du. Wow! Exactly sine inverse. So we now have it exactly as what? Sine inverse. Therefore, we can say that this will give us 1 over 4. 1 over 4. And the integral of this is what? Sine inverse of u plus c. And we know that u is equal to what? 4s. So, but u is equal to what? 4s. Therefore, 1 over 4 sine inverse of u plus c. Oh, u is what? 4s. And that becomes our what? Final answer. Wow. I hope you are relating something. So the 4 we have here is now 1 over 4. I hope you can relate something. Alright. So let's look at our second example. So where should I claim? Make sure you write it. Are you done? Alright. I want to start solving from here and go to the right hand side. Okay, let's have integral u to the power s over u raised to the power 2s plus 1 ds. Okay, wow, we just finished how to integrate a natural log. Okay, so exponential function, so we should be able to do it. So this is going to give us, we know that this is the same as e raised to the power s all squared plus 1 dx. Wow! Then we can say that let u be equal to e raised to the power s. And if u is equal to e raised to the power s, du over ds is going to be e raised to the power s. Then, hope you can see that. We can write ds here. So e raised to the power s times ds is exactly du. So du is equal to e raised to the power s. Oh, so ds is equal to du is equal to e raised to the power s times what? ds, and that is exactly here. Or you can also make ds as the subject and come and do substitution, it will cancel out. It's the same thing. Oh, I want to get it for a reason. Alright, so now the integral of e raised to the power s ds we have on top there is exactly du over what we have there is u squared plus 1. Very good. And this is exactly relating to something here. Okay, please. If you can see that, you can also do it this way. ds is equal to what? Du over e raised to the power s. So when you come here, e raised to the power s over u squared plus 1. We are doing substitution to this. And ds is du over 2. Du over e raised to the power s. So this cancels this. I hope you can see that. So now we have it in terms of what? U. And this is exactly tan inverse. Exactly tan inverse of u plus c. But u is e raised to the power s. Therefore, we get tan inverse of u e raised to the power s plus c. Very good. Hope you understand. Trust you. Alright, next question. power 1 over s. 9s squared minus 1 ds. Nice. Straightforward. We can let this, we can rewrite this as 3s all squared, knowing 339 minus 1. And now let our u to be equal to, what do you think we should let our u to be equal to here? That can help us. Alright, that is the inside, which is what? 3s. So du ds is going to be 3. Therefore, ds is going to be du over 3. Hope you are following. Alright, so by substitution we get 1 over s square root of u squared minus 1. Oh! And the ds we have here is du over 3. Wow! So we have 1 over 3, integral of 1 over s u squared minus 1 du. So this s is still playing stubborn. Because we know that anytime we take the u and we integrate, it comes and remove that variable, but that variable is still inside. And we can't take integration in as respect to u, whereby we are having another variable which is not u inside. Very good. But we can still solve it, okay? Don't forget that we know that u is equal to what? 3x. So you can make s a subject and you get s to be equal to u over 3. So when you get that, then you come and do the substitution. U over 3 square root of u squared minus 1 du. Now we have all in terms of what? U. Wow. Do you know what is here? The constant here is 1 over 3. And that is only multiplying this 3 down here. Be careful. Oh, I have been doing the question. That is only multiplying this. It's not 1 over 3 times 1 over 3. Hey, it's not like that. If the numerator and then the denominator. So you get integral of 1 over u square root of u squared minus 1 du. So this take away this, you have integral of 1 over u squared minus 1. Oh, mathematics. So that is exactly sec inverse. That the absolute sign here means that this can be what? Negative. So if it's negative, it will be positive. Alright? And we exactly have sec inverse of u plus c. But u is 3x. So sec inverse of 3x plus c. And that is exactly what we have. Woo! I love applause. Good. Let's look at our last 2 or 3 examples. Hope I can clean that. Whenever I block your view from writing, you make sure that if I move from that place, you pause the video, then you write. Then after that, you play back. Is that clear? That's why I shift myself. So now we have integral of 1 over square root of 25 minus s squared dx. This may be our last example. Now watch. We can rewrite this as 1 over square root of 25 multiplying by 1 minus s squared over 25. Ooh, algebra! That is algebra! Yes, we can do that. I'm not asking you. We can do that. I don't want you to say whether yes or no. Because when you multiply this by this, you get that. Alright? And when you multiply this by this, you also get that. So it's the same thing. It's the same thing. Okay? We have just split it. We have just split it. And when you do that, it will come and divide the one here so that you can assure equality. Okay, so that is exactly the same as that. And now, this is the same as 5 square root of 1 minus s over 5 squared. Yes. All that we are doing is that alright, so when you do that, that's going to be the end of the results. See you for the next video.